Welcome to this session on the great architecture restructuring. My name is Juval. We're going to spend the next hour or so reflecting on not just the state of our industry, but the state of the world. We don't operate out of context. We operate in the context of the economy, the world, and I'm going to present to you my thoughts on how what is going on in the world today is going to shape the trends in the industry. I see on the participant window many familiar names. For those of you who invited friends and such, here's a few words about myself. I'm a software architect. I'm the founder of iDesign, a company I started 21 years ago, devoted for nothing but software design. Before iDesign, I was the chief software architect of a Fortune 100 company in Silicon Valley, and I managed the architecture department. Before that, I was division architect. Before that, just an architect. I'm at the beginning of my fourth decade as a software architect. Over the years, I've had several fundamental breakthroughs in software architecture, such as microservices. I've helped, and iDesign in general, I've helped hundreds of companies all over the world meet their commitments. And my masterclasses have launched the careers of thousands of architects the world over. I published more than 100 articles and 8 books. Latest one is Writing Software. I speak at conferences. I never worked for Microsoft, but I was part of the C# design effort and the WCF design effort. Microsoft recognized me as a software legend, something they only gave to 6 people so far due to the impact I've had on the industry over the years. And so why this presentation? It is my opinion that the economic crisis of 2020 is the most important event of our careers. And in that respect, I may not be telling you much news. I mean, we all know that the economy in 2020 suffered a major blow. What I will show you tonight is it was more than just a garden variety recession. It is a fundamental change to the systems of the world. And we all know that many businesses are facing difficulties, but especially in software, I believe many businesses are not going to survive. And we're going to discuss what it means. Those that do survive are going to face stringent demands by management and owners or investors to restructure. The party is over. Everybody's going to be expected to do more with less. Now, merely reduction in force is not going to work. And the reason is the failed state of most software systems. We all know that the average software system on a good day is a giant ball of mud. What will you do if you take away the few people that even know how to make sense of it? And so just reduction in force is going to make it worse. The key to our survival as an industry is restructuring the system architecture, and we must enable to get by with a fraction of the previous staffing and cost. This must be, of course, accompanied with rigorous project design to find the optimal use of the scant resources, budget, and time that you're actually going to have. And so, with that grim opinion, let me start substantiating it. We all know that the world economy is in the toilet. You could say that every advanced economy is on life support. Now, while most would say yes, and it was because of COVID, I don't think that's actually the case. I think the economic crisis of 2020 started before. And here's why I'm saying that. You could actually start seeing cracks in the dam. Here's a chart of an esoteric economic measure called the US overnight repo rate. Many banks, if not all banks, at the end of the day may not be balanced. They issued too many checks, took in too many loans, and so on. And so you have to balance the book. The way they actually do it is they get loans from other banks. And the following days, they basically repay the loan. They may supply as collateral US Treasury notes. Now, since they repurchase it, what's called the repo, they repurchase it in the morning at a high price, it is as if they actually paid interest rate on it. And there's nothing wrong with this process. In fact, it's like the lubrication of the financial system. Except in late 2019, the repo rate spiked to 10%. Now, I'll let you just think about it. You're getting in your checking account sub 1%. What is 10%? The reason that it spiked, initially it spiked to 6 or 7%, and then even to 10%, is because the economy simply reached the dead end. What actually happened is the economy reached debt saturation. For too long, the governments of the world and the central banks have kept interest rates too low. I'm old enough to remember getting on my checking account 4, 5, 6%. Nowadays, you're getting 0. Now, if the interest rates are held too low for too long, then capitalism itself stops working. And what actually happened in late 2019 is banks stopped trusting each other. And we're talking the brand name, the largest banks in the world, start having doubt that if they lend money to other banks, that in the morning they're going to get their money back. Meaning they suspected that other big banks are going to collapse during the night. And as a result, they demanded higher and higher repo rate to compensate for that risk. Now, if the big banks who have a solid understanding of what is going on stop trusting each other, what should you think about big banks? Now, as a result, in late 2019, the US Federal Reserve started a massive quantitative easing program. Now, quantitative easing is a fancy name for saying printing money out of thin air in the many, many billions and shoving it into the vaults of the banks to prevent them from collapsing. Here is a chart of the balance sheet of the US Federal Reserve. In essence, when they print money, when the US Federal Reserve is printing money, they actually increase electronically the balance sheet. Now, we all know the amount of money printing that happened in 2020. And I'll take a laser pointer here and I will show you, this is what COVID did. But notice what happened in late 2019. This is because of cracks in the dam. This is because the economy started collapsing even before COVID. COVID was basically the last straw. It was a big straw, but it accelerated a trend that was already happening. Here's some other morbid numbers. 20% of all US corporations are zombies. A zombie corporation is a corporation that cannot fund the interest rate on its loans based on operational income. Now, when a person reaches that, or a regular company, we call that bankrupt. Now, note that this trend has been going on since about 2010, but as you can see, 2020 has accelerated that. We all know there's high unemployment. What you fail to recognize is how acute that unemployment is. The correct unemployment numbers in the US is 25%. Now, the official numbers are a lot lower. The official numbers are around 10 or 15. That is simply because the US government does not account unemployment the way you and I would. For example, if you're sitting at home not looking for work, you are not considered unemployed. If you only find part-time job while you're actually interested in a full-time job, you're not considered unemployed. If you're an engineer but you can only find work in McDonald's, you're not considered unemployed. If you're getting welfare and you're fine with it, you're not considered unemployed. If you account for those things correctly, unemployment went as high as 35% and then stabilized at 25%. Thankfully, there's a website called shadowstats.com that correctly accounts for these things. They do similar shenanigans with inflation. Here's a chart from the US Federal itself. This one lists the US government deficits. Now, I've taken a long-term view here of more than 100 years, just so we can see the magnitude of what really happened. So you can see World War I, which basically is invisible in this scale. World War II is actually visible, but not much. Vietnam War, all the social welfare programs of the 60s is barely noticeable. The dot-com bust is noticeable, followed by the 2008 global financial crisis, And then we have 2020. To say that 2020 is unprecedented is an understatement. This has never happened before in the history of the world. And it's not just the government sector. Whole industries collapse. Think about what happened to airlines that have to cut 90% or more of their airplanes and fleets. Think about what happened to transportation, not just trucks, but shipping and containers. Consumption of energy is completely collapsed to the point that oil went into minus 47%, meaning the refineries were so clogged with oil they had to pay to take the oil away. Entire supply chains, starting in China, ending up somewhere else in the world, collapse. People stop looking into entertainment, restaurants, and movies. When people stop going to work, they stop attending offices. Now, landlords in city centers rent office space, and then they use it to produce income. Now, when they don't produce income from that, that becomes a dead asset. And many have stopped paying their commercial mortgages. And that triggers some kind of banking crisis, anybody that deals with commercial real estate. In fact, anything to do with city centers, initially, because of COVID, later on, because of the right and such, becomes a desolated landscape. Here is a headline from late 2020 estimating that 60% of the businesses that closed in 2020 are not coming back. The way the governments of the world, and I'm showing you US numbers here, but this is true in any country, responding to it is by massive printing of money. Here is the US M1 money stock. M1 is what most people would regard as money. And you can have broader terms that include also credit and such, but by and large, this is the money supplies in the US. And you can see it's been on an ongoing trend, and that's probably a good thing, because if the population is growing by, say, 3%, you actually increase the money supply by 3%, or you're going to get shortage of money, and we may actually even encounter deflation as a result. And so some slope on that line is okay, but then there's some events. For example, you can barely see the dot-com bust, followed by 9/11, and then the global financial crisis of 2008, and then 2020. In 2020, the US government, via its agents in the Feds, have printed 375% of all the money ever created. This is such an unbelievable number, I'm going to say it again. They've printed close to 4 times of all the money that ever existed. This was so embarrassing, they actually stopped reporting the data. I'll let you think about that for a second. So I don't know how much the money printing is standing now, because they've stopped reporting the data. They say there's no public interest in finding out the data. Now, this is not just the US. Here's a headline from late 2020 that the British economy will shrink the most in 300 years. Now, what we have here is 2 very powerful forces. On one hand, we have collapse of industry, collapse of supply chains, collapse of workers. People in China did not go to work. Truckers in the US did not ship containers. At the same time, the amount of money chasing the reduced amount of goods triggered massive and acute prices and spikes. In fact, all over the world, there's massive shortages in food, in construction material, in electronics, in everyday appliances, in cars. I'll show you a few examples. There's literally dozens. Here is what happened to the price of corn in 1 year. In 1 year, the price of corn went up 80%. Now, you may not actually think that's a lot, but most of the world, their main expense is food. And US corn probably provides a very good percentage of the world food supply. And if corn goes up, what happened to soybean or rice or wheat? There's revolutions when the price of food goes up by a lot less. Here's what happened to lumber. In 1 year, it went up 350%. Now, lumber is important in the construction of housing. So as the population grows, you build in the US, most homes are actually built using lumber. What happens to the price of new homes when it's up 350%? Now, it's not at the price of the home, because it also includes metal and labor and such, but it gives you an indication of the collateral effect this has. And it's not just simple things like lumber or corn. There's a global shortage of computer chips. In fact, if something uses electronics like a smartphone or a car or a laptop, the manufacturers can't do it. In fact, Samsung has canceled the next version of the Galaxy simply because they can't get enough computer chips. Car manufacturers in the US have stopped producing new cars because they're missing a particular chip somewhere. Now, I could go on, but you get the idea. Where is this probably heading? We're probably, and this is an opinion, heading to a 1970s style stagflation. Stagflation is the combination of two words, stagnation and inflation. Now, normally these two words do not go together. Normally, if there's inflation, there's actually some kind of economic boom. There's lots of velocity of money in the economy. People demand raises, they spend more money. And if the economy stagnates, they have less money to spend. And as a result, the money supply and money velocity stops or slows down. And as a result, prices actually go down. Stagflation is a unique case where you have both stagnation of growth, stagnation of the economy, and acute inflation. This has already happened 40 years ago in the 70s. In the 70s, it was a combination of the US going off the gold standard in 1971 and the Arab oil shock. And of course, oil is such an important ingredient of manufacturing of pretty much everything, as well as transportation of everything that's not manufactured using oil, that these two things at one hand created massive inflation, massive shortages, and stagnation in the economy, because the economy by and large cannot operate very well when it has shortages. Plus, in a situation where there's high inflation, people don't take risks, they don't invest, they can't open new factories, and the economy by and large stagnates. Now, the last time the world has experienced such stagflation was in the 1970s. It is my opinion what we're facing now is considerably worse. First, I showed you numbers that are inconceivable as far as the cost push inflation amplification. And I'll show you in a slide that the rates of inflation we are going to experience are literally unheard of. The amount of money printing that has happened is unheard of. All of that is on top of a much weaker economy, to the point that big banks don't trust each other. People would rather stay at home than actually work in low-paying jobs. And the reason there's low-paying jobs is because there aren't enough high-paying jobs. And so the economy of the 1970s, not just the US, but of the West in general, was a much stronger economy than today. Today, the economies of the US, the UK, Canada, Australia is all a debtor economy. All the governments in the West are in debt. In the 70s, the US was the world's largest creditor. Today, the world's largest creditor is China. The US and all other countries have trade deficit with China, and the Chinese are buying US bonds. And so the foundation of the economy is a lot weaker than the 70s. And so you might want to do some research or talk to your parents what it was like to live in the 70s. I can tell you it wasn't that much fun, and we're going to have it on steroids. Here is another headline for you. Last one in this section on economy. This is from a week ago. It talks about the rate of inflation that hasn't seen in 30 years. Now, what they're actually saying here, and I have to translate it to you, they're saying that the May core personal inflation expectation rose 3.4%. So two numbers here. First, 3.4% annualized is 20%. So based on what has happened last month, we should expect 20% annual inflation. That means that all your life saving is being reduced by 20% on an annual basis. And after 3 years, you lose half your life saving. Think about that for a second. Furthermore, what does the word core actually mean? It turns out that the US government doesn't like the real inflation numbers. And so when they measure core inflation, they actually exclude the following: energy, food, and health. Because you see, those things are not core. They are just too volatile to be included. And so the inflation numbers you hear in the news are grossly undercounted. So if the grossly undercounted numbers are 20%, what's the real number? Is it 50% inflation? I do not know. I do know that businesses cannot plan when it's 20% inflation, and probably cannot plan when it's 10%. And remember, in the bank, you're still getting under 1%. And so this is the economic background, and the software industry does not operate in the void. Our industry is, in the context of the world, and the money that we make and the service provider in that context. So if we start talking about the software industry, even before 2020, the software industry was in a deep crisis. Literally every aspect of software development was broken. Schedule was a useless concept. If any developer met any schedule, everybody would be surprised. Cost was also pointless. If you ask developers how much would it cost to develop the system, they would give you a blank stare. Nobody has any means of even answering the question. You may get answers like, we have to build it to answer that question. Now think about it. How can you run a business when time and money do not matter? You couldn't operate a hot dog stand if time and money does not matter. And yet in the software industry, people try to maintain the fiction that time and money does not matter. And then they glorified it and they made up all sorts of processes that disregard time and money. Requirements were completely broken. Quite often developers solve their own problems with perpetual miscommunication between customers and developers. And we're going to talk about that most people's code cannot handle changes in the requirements. Software is so poor quality that everybody has defects. In fact, everybody takes it synonymous that software has defects. Staffing is out of control. Even if somebody knows how to do something right, but not somebody is gone, the people left behind cannot make sense of it. As a result, they make it worse. Now, I'm painting with a broad brush. Obviously, people are doing it right, and there's plenty of examples. But in broad strokes, that's what's going on. In broad strokes, most systems have very high level of complexity. People talk about they have technical debt, but nobody ever stops to ask, how did the technical debt end up in the code? And what will you do to prevent it from happening in the next version of the product or next time you're going to do it? They think it's ordained. It's like part of the cosmic firmament that software will have technical debt. It's like in the software world, there's actually three things which are guaranteed: taxes, death, and technical debt. Now, technical debt is not just a complexity. It's simply lack of ability to respond to changes. It is always possible to respond to changes, but the cost of doing it is so prohibitive, it might as well just do the whole system from scratch. Now, these problems are direct result of system design. Most people, when they design a software system, if they design it at all, most people just try and have it grow organically like a tumor, is they reflect the required functionality of the system in the architecture. Literally, you look at chunks of requirements and there's blocks in the architecture: invoicing, billing, shipping. Now, the problem with this approach should be self-evident. Requirements change, and that's actually a good thing, because if requirement would never change, no software developer or architect would have a job. The essence of the job is to respond to changes. If the requirements would not change, the software developers would have no job, because somebody in the past would write the software once, it'd be good enough, and that would be it. And so requirements actually is what keeps everybody employed. And yet, if you design against the requirements, when the requirements change, then the system architecture has to change. And it turns out the change to the architecture always result in out of control duration and cost. And it's true not just in software. If you have a single family home, one floor, and you want to change the architecture into being a shopping mall, that's a very expensive cost. The moment developers have already implemented the wrong design, and you force a change to the architecture, it is horrendously expensive and frustrating. It basically creates pain and frustration all across, not just developers, between the organization, managers, developers, customers. And here's what Scott Adams has to say about this problem. Well, you know, if there's a Dilbert cartoon on it, you know it's true. But there's more problems beyond the inability to respond to change that makes designing against the requirements be a complete exercise in futility. Whenever you build a system out of smaller building blocks, be it component, module, services, subsystem, whatever the units of granularity is, you have to pay for the cost of building the building blocks, and you have to pay for the cost of putting these building blocks together. And so you have the integration cost and you have the implementation cost. And you always have these two costs. The question is, how does it affect the total cost of the system? Now, you can actually, in a qualitative way, plot it. So I have it in blue, the cost per service or per module. And obviously, the bigger the service is, the more complexities. The more complexities, the higher the cost, and probably in a non-linear way. Something twice as complex is not twice as expensive, it's 20 times as expensive. Similar things happen with the integration. If I only have few things to integrate, I don't have a lot of integration costs. But if I have many things to integrate, the cost of integration is non-linear to the number of things that I have, because as I integrate them, they have ripple effects all across. And so you have to pay for, in any system, for these two elements of cost. Now, a system that has very few things, maybe even just one big thing somewhere in here, has very little integration cost and very high implementation cost. A system, on the other hand, that has lots of little things may have very little per service implementation cost, but incredibly high integration cost. And these two lines are non-linear. Non-linear systems behave in extremely non-linear ways. The changes here can be 2, 4, 200. Now, obviously, in any system, there's a sweet spot where the system has not too many components, not too few components. The components are not too big and not too small. And so you can actually see here in the dashed green line, I've summed up the blue line and the red line. And in any system, you have to pay for these two elements of cost. And actually, I can show you here that any system has this point of optimal design. Now, you want to design a system around this area of minimal cost. The edges are non-linearly worse. What is non-linearly worse? Twice as bad, 4 times as bad, 400 times as bad? Nobody knows. Now, think about designing against the requirements. Your system is not going to have just 3 things, ABC. It can have 300 things to do. So one possible design is 300 little blocks, in which case you have non-linear integration cost. Now you could have the following. You have ugly dumping ground components that have the A and a B and a C, the giant inflated monoliths of doom, which have insane level of complexities. And it turns out that design against the requirements tend to gravitate to these extreme ends where you have to implement a non-linearly worse solution. Here's a visualization of what such solutions look like. Think about some human being has to make sense of what is going on in this system. You think any human being can make sense of it and not commit mistakes? Now, these problems are not new. And for decades, the solution was to throw people on the problem. Most software organizations have an army of ants mentality, just more people. I've measured it, and I found that when they were working incorrectly, they had hundreds of percent, hundreds plural, of overcapacity compared to what they should have had. I remember showing to customers how to build a system with 4 people, when in fact they've used 24 or even 40 people. So we're talking 600%, 1,000%. These numbers are not unheard of. Now, obviously, a factor of 6 or 10 is a huge factor, but even a factor of 2 or 3 on what you should have been doing is incredibly expensive. Hardly any team in software ever tries to design the project. Nobody ever asks, what is the fastest way of delivering? Now, the fastest way of delivering is not to code like hell. And the reason is whenever you have a bunch of things to do, you have a number of activities, and they all have certain duration. You have a number of people to do it with. You can actually think of your project as some kind of a network of activities. And you can actually find a path in that network that is the longest duration. And it's called the critical path. Now, since no project can be accelerated beyond its critical path because it is the longest path to all of the activities based on their dependencies and availability of resources and such, then it stands to reason that in order to build the system the fastest possible way, you would build it along the critical path. But nobody ever tries to find the critical path or assign people along it. And as a result, the only way to compensate is crazy overcapacity. You throw people on the problem, some hit the critical path, some don't, and maybe you build the system. Now, nobody ever asks what is the cheapest way of building the system. It turns out that yes, you cannot accelerate the project beyond its critical path, but what is the lowest level of staffing required to progress unimpeded along the critical path is a very important question, because that level of staffing will find for you the cheapest way of building the system. But again, nobody ever asks that question. Nobody ever asks, what does it take to actually reduce the risk in the project? Nobody ever tries to find what is the most efficient way of employing people in the project. Why? Because it's an army of ants. All developers are warm bodies pounding on keyboards, get more keyboard, gets more warm bodies pounding on the keyboard, and that's the solution. And this is not news to most people. Most software organizations are utterly chaotic. I say it's as if a mob is trying to write software. If somebody even figure out how to do something and that somebody is gone, the knowledge is gone forever. If somebody does manage to meet the deadline or the budget, that's a miracle. Nobody can ever repeat that achievement. There's no productive process. The productive process you should have is a process designed to maximize everybody's level of productivity. And yet the process most people choose is a process designed to maximize everybody's level of inefficiency. For example, if the only strategy is to throw people on the problem, that means the teams are larger than what they should be. Larger teams have a fundamental large communication overhead. In addition, if you design against the requirements and you have these giant balls of mud with insane complexity inside the components and complexity between the components, and you assign people for doing it, then the people, when they work in the team, reflect in their interaction the complexity of the architecture. And there's going to spend enormous amount of time resolving the issue of all the cobwebs because it reflects their interaction. So everybody has to be in meetings, everybody is stepping on everybody else's toes. It is as if they have adopted a process designed to maximize everybody's level of inefficiency. There's hardly ever any development standard. The answer for everything is we're doing Agile. Now, it's not as if you're the only one knows about this dirty laundry. The truth is getting out. Here's an article from The Atlantic. Software runs the world. How scared should you be that so much of it is so bad? Now, The Atlantic is not Dr. Dobbs or MSDN. This is a magazine for the general public. This is what you will find in your dentist's waiting room. The world is waking up for this. Now, this article is from 2012. Yeah, nobody did anything about it. In fact, it has gotten a lot worse over the last 10 years. It is my observation that the software industry has given up on engineering practices. Engineering is fundamentally about planning and design. Engineers is not about work. For work, you have technicians. Engineers is about laying out what you need to do against the deadline, against the budget, deciding what's the best way of meeting it. The word engineer is synonymous with the word design. And yet the majority of people in the software industry practicing it for a living were never taught design. Not just software design, any kind of design. Part of engineering is accountability. If an engineer designs a bridge and the bridge collapses, we expect the engineer to go to jail. But when a jumbo jet crashes and hundreds of people die, how come the developer who had a bug with resetting the counter didn't go to jail? There's no accountability. In fact, when the developers fail to meet their commitments, we keep paying them a salary. There's no accountability. Well, you know what? If there's no accountability, why do you expect people to ever change their behavior? There's severe lack of integrity. Fundamentally, when things don't work, people blame other people. They don't have the integrity to say, I messed up, or I will learn from my mistake and I will do it better next time. People don't treat the company's money as their own money. So what? The computer in the sky is paying paychecks. I don't care if it takes another year. There's an acute knowledge shortage. Hardly any developer is properly trained in the technology at hand. Hardly any architect or somebody who's an architect is ever trained as an architect. Hardly any software manager is ever trained on how to manage a software project. Now, part of engineering is being a professional where the basic expectation is that you know your craft and your trade by heart. And that is not the case in the software industry. In fact, the level of hubris leading people to believe that every few years they can waltz to a whiteboard, draw a few lines and absolutely nail the design. I don't even know how to respond to that. How could you possibly do that? Nobody ever tries to improve. Again, the fact that there's technical debt and you fail to meet your commitments, that's not a reason to try and clean up your act. The over lack of competence is staggering. Now, all other engineering domains are regulated. You can't call yourself a bridge designer. You have to be certified, licensed by the state to be a bridge designer or a civil engineer and such. But in software, sure, anybody can be a software engineer. They can put the word engineer on the business card and now they're an engineer. They were never trained as engineers. And now what? Like I said, it's as if the industry has given up on engineering. In fact, software today is not practiced as an engineering discipline. It's not even perceived as a profession. When you say to somebody in software development, they'll say a geek, a hacker. And if you think about what does it actually mean, the army of ant mentality of throwing people on problems, that means that every person doesn't add a lot of value. And from the business perspective, that's actually right, because do these people actually make me meet my commitments? Do they help me plan? No. So they're just basically manufacturing workers. Now, look at the process of over the last 30 years. Manufacturing jobs have left the developed world to places where they can basically pollute the environment and pay them basically slave labor. And why? Because it doesn't add a lot of added value. You know, Apple sent to China the soldering of the iPhone, not the design of the iPhone. That is high added value. That's stayed in Cupertino. There's a huge skill gap between what most developers know and what they should know across every aspect of technology, design, process. And strictly speaking, you don't care about the knowledge gap, you care about the capability gap. There's a gap between what they should be able to produce and what they do produce. Here's what they should be able to produce. They should be able to produce impeccable software on schedule and on budget. That's it. I'm not even saying they should be able to produce impeccable software the cheapest and fastest possible way. No, I'm just saying on schedule, on budget. Please mute yourself. And so it's not just limited for developers. Most managers are their own worst enemies. I say they only have two management styles, death march and lucky strikes. What is a death march? You keep plodding ahead, plodding ahead, and if you stop running, they put a bullet in your head. That's basically the management style. Code like hell and hope for the best. Or like a strike, you think it's going to take you a year, it took you a month. Applause. And then it gets worse. For 20 years, since publication of the Agile Manifesto, developers promised agility. Every developer has said the word agile and agility millions of times. And yet, categorically, they fail to deliver agility. You know, if you think there's technical debt in your product right now, technical debt is fundamentally the inability of responding to changes. And so on one hand, everybody is saying agile. At the same time, they fail to deliver agility. Now, to compensate for the lack of agility, we have rituals. In fact, the industry is obsessed with rituals. And they all have their favorite flavor of the religion, be it Scrum or Kanban or Lean or whatever it is. And fundamentally, all they're doing is rituals. They are praying at the altar of doom for salvation, but there's no salvation. Rituals don't actually prevent you from going to hell. And indeed, software development for many is hell in spite of the rituals. There is no essence in the rituals. People are way more interested in doing agile than in being agile. In fact, agile by now has metastasized to being a fig leaf for doing the wrong thing while gloating for doing the right thing. Fundamentally, developers actually don't want to do agile. Developers want to code. Nobody goes in software development because they hate coding. They go into software development because they love coding. Now, in a well-run software project, coding is a small fraction of the actual volume of work. Because it's not just coding. How about unit testing, integration, documentation, installation script, code review, design review, requirement review, test plan review, sitting on code review, requirement review, test plan review of every other developer in the team. Coding is at best 20%, and probably more like 10%. There's an age-old comment that developers only write 3 lines of code a day. Now, if you go into doing a particular trade, I hardly want to call it a profession because it's not professional the way it's done, and all of a sudden, the one thing that brought you into it, you don't get to do, you're going to find ways of changing it. Agile is a way for developers to basically change the equation. Instead of 10% coding, 90% all the other things, of doing 90% coding and 10% rituals. And so when developers say we need to do Agile, we must do Agile, they actually mean we just want to code like hell till the end of the world. In fact, the fact that we have no idea how much it will cost, if we even have enough time for doing it, that's just okay, because anything else is not Agile. It's just a fig leaf. At the same time, we have management. For most managers, Agile is a wonderful excuse of not doing the right things while gloating at doing the right things. In many environments, if you stick your neck out and try and do things correctly, it's a risk. Why? Because if the software is late, it was going to say, well, you didn't do this, you didn't do that. And so the only strategy is code like hell for managers. Being a good software manager means taking risk, means carving and blazing a trail in the jungle for the team to be productive, often fighting everybody else in the organization to work correctly. But who wants to stick their neck out? You say, well, I'm just doing Agile. Again, here's what Scott Adams has to say about it. But there's more to it. Agile lets practitioners skirt the issue of not knowing how to do design, be it the design of the system or the design of the project. It lets them pretend it's not needed. In fact, if you try and introduce design into an Agile environment, they're going to say that's not Agile. First of all, that's false. But beyond that, how would they dare call themselves engineers? Because engineers is synonymous with the word design, while at the same time, they basically negate any effort of doing design. Now, that is not an accident. If your job is to be an engineer and you need to provide design and you don't know how to do it, you should feel bad about it. People don't like feeling bad. And so they say, we're going to do Agile, where we can pretend it's not needed to do design because we're going to add value early, often, and soon. Now, it's even worse than that. The lack of design is evident. I showed you the giant balls of mud. And so they have to pretend it would be bad if you were to try and do design. That's how bad things are. Now, the knowledge gaps I mentioned before are so acute and so wide, hardly anybody's doing it right. And that means that people spend their entire career in the software industry not seeing software done right even once. Now, it's one thing if you don't know how to do it, but Bob over there knows how to do it, and the software is maintainable, extensible, reusable, on schedule, on budget, then obviously it can be done, and then you feel bad about it. But they've never seen anybody else doing it. Again, if they don't know how to do it, you should feel bad because that's their job. They've never seen anybody else doing it. So now they conclude it cannot be done. Now, this is, of course, a logical fallacy. Why? It's because they're actually confusing absence of evidence with evidence of absence. The fact I've never seen it done doesn't mean it can't be done. It just means I've never seen it. And then it gets even worse, because when you try and work correctly in such an environment, you're trying to do something they've already concluded is impossible. Now, they've never seen anybody else doing it, and so they conclude it's impossible. So when you try and work correctly in such an environment, you're trying to do the impossible. And when you try and do the impossible, you actually insult those that have concluded it is impossible. You're insulting their intelligence. And so they fight you trying to do the good thing. And the result is an entire industry obsessed with working the worst possible way. The Agile Manifesto and Agile as a movement was brought in to fix the problems of the waterfall of the 80s and the 90s. 20 plus years later, are we any better off? So I say the way the industry is doing it is a disease masquerading as its own cure, because Agile was brought to fix these problems and made them worse. Now, there's consequences for not working correctly. Fundamentally, the lack of upfront knowledge of how long will it take and how much will it cost doesn't allow decision makers to decide if they even want to do it. And if they want to do it, under what terms? And as a result, there is no way of killing in advance project that should never be done. Meaning, if this is a 3 years project, but you only give it a year, what do you expect will happen after a year? Or if it's a $3 million project and you only give it $2 million, what do you expect to happen once you burn through $2 million? The inability to know these things in advance and have educated decisions has drastic consequences for the careers of everyone involved, for the money of the investor, the customers, the projects, the organization. The mortality rate, therefore, software project is ridiculously high. Now, I mentioned to you that the inability of doing it the fastest and cheapest has implications. In fact, Murphy says that because you don't try and do it the fastest and the cheapest, you're likely going to do it the slowest and the most expensive. And again, if you don't know what the critical path is, you're going to compensate with overcapacity. If you haven't done the architecture, then you have a ball of mud. If you have a ball of mud, it requires many more people than just the lowest level of people required to manage and execute a well-designed system. And this is not specific to software. We all know the stories of the three little piggies. One piggy builds a home out of straw, and the big wolf comes and blows. And then the piggy runs to the house of the piggy that builds a house from wood, and the wolf blows. And then they all go and hide in the house of the piggy that builds it out of bricks. And of course, while the piggy was building it out of bricks, the other two piggies were laughing, ha 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 ha, that's not agile. Now, this fable was told to many people, probably you all, when you were young. Do you think the fable is not true because you're an adult? Do you think a well-designed system is worse off than a system made of chewing gum and mud? I mean, in what world would this make sense? And then people have to glorify their incompetence because they cannot design things in advance. And they would say, it's big upfront design, it's bad. Remember, they have to live with themselves. They have basically perpetual infatuation with refactoring. They constantly refactor. And nobody ever stops to ask the question. Okay, suppose we started with a giant ball of mud. Let's refactor something good and we stop. Isn't perpetual refactoring perpetual inability of ever getting it right? In which case, why engage in the first one? And by the way, do you have any quantified way of knowing that you haven't made it worse? Why would you let the same people that did not know how to do a good job in the first place do a good job in the second, third, fourth, and infinity places? It doesn't make any commercial sense. But again, they glorify these insane practices to live with themselves. You know, this is not a cartoon. This is a real serious question. If you're trying to build something like a bridge, how far can you get without the design of the bridge? If all you have is half-nailed boards, all you do is sprints. In fact, you think sprints can ever be back-to-back? How much time is required between sprints to plan, to design, to train, and then to execute the sprint? I've never met anybody in the software industry that even knew why sprints. If I asked them why you're doing sprints, they said because that's how we do agile. Okay, that's not an argument. That's just a ritual. They could never ever explain to me why sprints until I explained to them why sprints and how to do it correctly. Now, the Romans had a saying, pede pona claudo, punishment comes limping. The problem is that you're not going to get punished when you do the first crooked sprint, the first board with half-nailed nails in it. You're going to get the penalty for it maybe sometimes a year later, maybe years later, when someone's going to try and maintain it and they can't because it's a giant ball of mud. Now, while speaking of Agile, I'll tell you what I think is going on. I think Agile is a failed counter-revolution. What does it mean? Whenever something is bad, people basically revolt against it and they try and improve. Except, with very few exceptions, probably only two, human history is full of examples that counter-revolutions always made things worse. For example, under which ruler would you like to be? Under Marie Antoinette and Louis, let them have cake, or under Robespierre, off with their heads? Would you rather be under the Tsar in Russia, or under Lenin and Trotsky and Stalin and the gulags and the death camps? Under Chiang Kai-shek, or under Mao, that killed in the Great Leap Forward and the Counter-Revolution? Nobody knows, probably 80 million Chinese. Would you rather live under Batista with some corrupt mafiosis in Cuba, or under Castro? Would you rather live under Saddam Hussein, Gaddafi, and Mubarak, or the Arab Spring, some spring? Under the Shah in Iran, or under the Ayatollahs? With very few exceptions, counter-revolutions always make things worse. Agile is a case of a counter-revolution against the waterfall. Now, I've lived under waterfalls, and I saw firsthand why it doesn't work. Nobody is smart enough to design the whole system up front. I totally agree there's no point in doing a big upfront design, and I'm never actually advocating that. But I can tell you that the darkest day under the waterfall was better than the brightest day on Agile land, because At the waterfall, this was some semblance of trying to estimate, to plan, to design. It wasn't perfect, but something is better than nothing. Now, you cannot even say these things in most polite societies in the software industry. Why? Because you're basically destroying people's false idols. You know, in general, sadly, most people would rather be miserable than being wrong. To use an analogy, ask any diehard communist in the end of the 80s in Russia or East Germany, do you think communism worked? And they said, well, obviously not. Okay, then do you think it was a good idea or bad idea? Well, it was a good idea that we just didn't try it hard enough, right? And so if they would left to them, there'd be more gulags and more Stasi and more KGB. So people would much rather be miserable than recognize that what they've believed, and really it's a belief, it's a religion, was wrong. Here's a cartoon that tells you what I said before, that the darkest day under the tyranny of the waterfall was better than the brightest day in Agerland. Just go through it. I don't think much of what I described here is new to anybody on this call. Now, what are the consequences of what I described to you? Everything I showed you so far, everything that is broken was sustainable. Why? Because the money was flowing. There's a saying that a rising tide lifts all boats, even leaky ones. There was so much money in the software industry, nobody cared. Nobody cared. However, Robert Louis Stevenson said that sooner or later, everyone sits down to a banquet of consequences. The 2020 crisis is more than just a result of the economy. What it means is later is now. The software industry will have to face now the consequences of a decade of poor practices. The industry will have to clean up its act. What I believe we're going to see, it's an opinion, is a very strong Darwinism of the survival of the fittest, and businesses that would not adapt to what is coming will simply not be able to survive using the old practices in the new economy. And so what it is that you need to do? It is imperative to drastically reduce cost, not by a little, by a lot. Now, I think it's a good business practice to reduce cost even on a sunny day, but it is absolutely imperative in the face of stagflation. What does it take to handle, to manage a stagflated economy? Many organizations are going to face harsh alternatives. Many software teams are very thinly spread, right? And they're already incapable of contending with the complexity of what they have to deal with. If you reduce that team, you'll be simply running out of fingers to plug in the dike. Because remember, the only strategy is army of ants. But what if you run out of ants? What are you going to do? You will have to restructure everything. You have to restructure the architecture. You have to restructure the project, the people, and the process. I wish I could give you a magic bullet, some kind of a magical cure, just do it this, just do it what. No, when you have this kind of a multi-dimensional problem, you need a multi-dimensional solution. All of these aspects have to change. And fundamentally, the only viable option is to operate with a fraction of the previous level of staffing. And not just operate, but even do better. You know, there's always an opportunity for fixing things, and we have a good opportunity here. When you can start itemizing what it means here. When it comes to architecture, you must design based on volatility. Again, the crooked way most people design is against the functionality. They reflect the required functionality in the building blocks of the system. The correct way of designing system is based on volatility. You identify areas of change, encapsulate those in components of the system, services, modules, whatever you want to call it. And then when the change happens, it's contained. When you start thinking about volatility-based decomposition, you start thinking about your system as a series of vaults. Each vault contains potential areas of very dangerous change. When a change happens, it's like a hand grenade. It's very dangerous. You open up the door of the appropriate vault and you toss a hand grenade inside. And then you close the door of the vault. Now, whatever was inside the vault will be completely destroyed, but there's no sharpener flying all over the place, destroying everything in its wake. Now, think about handling change in an environment that has functional decomposition. When you design against the functionality, by definition, you do not design against change. So by definition, the change can never be in any one place. It is like swallowing a live hand grenade. And as a result, you need an army of ants to make sense of changes, and they have to change here, everywhere. And this would drastically reduce the need for larger teams. Just this idea. Now, if you follow my work over the years or read writing software, I can discuss structures and taxonomy and interaction rules between these areas of volatility. But if you just even follow what I just said, you would be doing a hell of a lot better than the alternative. You have to design projects. Just like you design system, you must design the project to build the system. You have to find the quickest, cheapest, or safest way of building any system. You have to find the optimal use of the reduced resources you're going to have. And again, I already hinted in one slide is what you need to do. You model the project as a network of related activities. You have effort estimation for each. It doesn't have to be even perfect. Make all of them be 2 days. Make all of them be 20 days. It doesn't matter. Just be something consistent. And then you identify the duration of the critical path, and you need to build a system along this path. You have to also determine the float. Activities outside the critical path have some amount of time you could postpone them without delaying the project. Now, not all of these activities are going to have the same amount of float. And so you have to assign the people based on float. You assign people to the lowest float activities. They are higher in risk. And now you find what is the safest way of leveraging the reduced resources that you have. You can even have some numerical models of calculating the risk and even choose the safest option of what you actually have. You start balancing cost and schedule and risk. This is a very visual process. You can see here in black a critical path, in red low float, in green high float. Follow other lectures or writing software, you will see how to do this. And you start actually crafting options, because there isn't just a single way of doing a project. Surely doing it the quickest is not the same as doing it the cheapest. And if you start plot how the various options relate to each other, you get some kind of a curve called the time cost curve that shows various ways of building the system. Each one of these points is some trade of time and cost. Now, if each point here is some combination of time and cost, the combination of time and cost that's above this line is doable. It's just not optimal, because for this amount of cost, I might, for this amount of time, right? If I'm willing to take this time, I might as well do it at this cost. Or for this amount of cost, I might do it this fast. So points here are actually doable, but points below it are impossible. So in fact, if you start modeling projects like this, you can identify a death zone. Combination of time and cost you shouldn't do. Now, as a result, you avoid wasting time. You avoid wasting people's careers and life and budget doing things which are simply improbable. And you only focus on the things you should actually do. And going back to system design, there's another thing you must do. You must strive to find the smallest number of components that can satisfy all the use cases, all the requirements. Now, first of all, why smallest? Because you're not in the business of doing more work. You're always in the business of doing less work, especially when you have reduced team and reduced budgets. Now, most people don't think about it this way. Most people would have 300 components because they have 300 things to do, or one giant component with 300 things. Now, the way to actually look at it is you are going to try and look for the core use cases. The core use case represents the essence of your system. This is what brings the customer to the door. Even a system with 300 use cases is going to have only a handful, 2 or 3 of these core use cases. Now, all the other use cases are just variation of the core use cases. What you then try and do is you find the smallest level of components that you can put together to satisfy each of the core use cases. Since all the other use cases are variation of the core use cases, what they therefore represent is a different interaction between your building blocks, not a different decomposition thereof. So now when the requirements change, your design does not. This is such a fundamental observation when it says the whole thing again. You're looking for the smallest set of components you can put together to satisfy each of the core use cases. Since all the other use cases are variation of the core use cases, what they represent is a different interaction between your building blocks, not a different decomposition thereof. So now when the requirements change, your design does not. Now, this is a stark departure from how people design systems. You never try to satisfy any use case in particular. It's pointless. The use cases are going to change. You're going to have new use cases. You're going to remove use cases. Now, because you're focusing on the small set of components that you can actually do it, you're not even doing new components. You're just putting them together in different ways, which is a fraction of the cost and time it takes to implement new behaviors. So now when the requirements change, you can very quickly and cheaply respond to it. Now, the ability to quickly and cheaply respond to changes is the essence of agility. I have nothing against being agile, except I just explained to you how to do it. Being agile has nothing to do with rituals. Whether or not to engage a Kanban board is irrelevant. If you don't do what I just explained to you, you are not agile. You are basically doing some kind of voodoo metastasized religion. But there's something else going on to working in this approach. I call this approach composable design. You don't design against the requirement. The essence of this design is the composability of what you create. But something else is going on here. The added value is in identifying those blocks. And you can actually further drill down and identify the interfaces and the design and find commonalities and so on and so forth. But the added value is what I just described. Putting these components together at this point is almost mechanical. It is truly manufacturing. Now, if coding is mechanical, why not have machines do it? Now, this is predicated on having the right architecture. We already have the smallest set of components that we can put together to satisfy all requirements, present and future, known and unknown. And now we just let machines do the integration, the compositions. And I think that the 2020 crisis is a force function, an imperative for people to start working this way and for tools to actually catch up. And I think that, and I mentioned in my master classes over many years, that this trend would actually happen. I think what happened in 2020 would simply accelerate this trend. And so I think that this is, unfortunately, the future for most developers. Now, if machines are actually going to do this composition, then machines are going to be the ones providing the agility. So I call the following idea artificial agility. Today we have AI. Could AI integrate the components? Now it's predicated again on the architecture. You have to do the right architecture. That's what enables it. But we let the architecture learn the requirements. We let the AI learn the requirements and then start devising solutions. First of all, there's only, if you have a small set of components, there's a finite number of combination, and many of them don't make sense. Like it's a bad idea for the database to call the UI. So you can actually give it interaction rules. And we can have the AI even do simulation, meaning take the current input and run it on all of these things and see if it made sense as well. And if you think that this is something that's somewhere far in the future, you are wrong. This is already happening. Here's a screenshot I took 4 years ago. AI learns to run its own code by stealing from other programs. Now, this is just clickbait. Nobody steals anything from anybody else, okay? What we have here is researchers at Microsoft that took an AI and taught it to solve programming tasks by copying and pasting from Stack Overflow, which is what most developers do anyway. And while this is a research project, if I had access to this technology and know what I would do with it, the first task I would give it is to write a better AI that writes code. And you know what I would do with that one? This is basically non-biological evolution. Now, people are working on these solutions. Here is a screenshot from 2019. It's called AI.codes. It's how to build different kinds of components and how to weave them together, assembling blocks of ready-made code, a core set of building blocks that makes it super fast to build an array of software. Interesting, sounds like composable design. Now, this particular company in Palo Alto took some kind of social media plugin, editor or something, and they wrote it by hand, and then they wrote it using their tool. And they say that it's 1,000 times faster to do it using their tool. Now let's suppose it's all hyperbole and exaggerating, and the real number is 100 times. Does it matter? Let's say it's 10x. Does it matter? The moment anybody would find a way of programming 10 times faster, everybody else would have very simple choice. Either they do it too, or they go out of business because they can't compete with them. And don't think for a second that the software industry would hesitate doing it. Every manager in every big corporation doesn't like developers. Why? Managers talk business, they talk plans, they have projections, they have budgets. Developers, it's like pushing on a string. You can't get any straight answer on any cost or any budget. Don't get me started on quality. And at the same time, when you ask them to do something, they say it's too long, it's too expensive, it's too this, can't be done, it's not agile. And they call themselves agile. So do you think companies are going to have any kind of misgiving about massive reduction in force once they have this ability? Now, arguably, for this to actually work, we're going to have the AI understand the spec. This has already happened. Here's a screenshot from 2018 when Microsoft AI beat a human on the Stanford reading comprehension test. Now, this is actually click-based. It didn't beat a human, it achieved parity with a human. And the Stanford comprehension test is a corpus of 100,000 questions that basically shows a paragraph of text, and then you ask questions about the text. And humans don't score perfectly on that test. They score 84%, and Microsoft AI for the first time reached 84%. Now, the rate of improvement on the Stanford test was so staggering. After another year of this test, Stanford had to change the test completely. And the reason is most AIs didn't actually understand the text. They actually wrote, what Microsoft did is they wrote an AI that's very good at the Stanford test. That's what they did. They didn't do much with understanding. And the reason is when AI is reading a text, it doesn't approach it like a human. When you read a piece of text, you bring to bear, as far as understanding, every book you've ever read, every movie you've ever seen, every conversation, every joke, and then you add information in the paragraph, and then you try and answer the question. AI doesn't do it. And so they start introducing the problem of context, asking questions that cannot be directly inferred from the text and so on. And I have the scores of that. So I went to the Stanford reading test website. I downloaded all the results that were better than 50%, because if it's worse than 50%, you're better off tossing a coin, and I plotted it. And here's the results. And you can see there's a positive trend there. And if you extrapolate it, by August this year, the AIs are going to get perfect scores. And it doesn't have to be perfect, it has to be better than a human, but it will actually be perfect in a matter of 2 months. Now, is Stanford going to revise the test again? Maybe. But I'm just showing you that these things are happening. Let's sum it up. I call this session Call for Action. I wish the party would have continued forever. Those of you in position of management and influence have to proactively lead the effort. Don't wait for the hammer to fall. Don't wait for your customers to run out of money and then you out of money. You have to drive the change. You have to be indispensable. You have to future-proof your architecture, your team, your project. And arguably, all of this would have been a good idea even without the COVID crisis. But we're running out of time and out of options as an industry. Now, I'm not kidding myself. Most players in the software industry are not going to clean up their act. And as a result, they're going to be crushed by what is coming. And at some point, even if they start massive reduction in force and such, it will be too late. The time to try and adopt and respond to this is before it happens. It is much, much better here to be proactive than reactive. You need to restructure the architecture, your project, the way people operate, and of course your process. Everything else is excuses. Let me give you some resources here. My book, Writing Software, published just before COVID hit, by the way, was supposed to go on a 12-city worldwide book tour. I managed to do only one city in Durban, South Africa. My book has many of the ideas I showed you today. It has composable design, quality-based decomposition, and of course, project design. There's also a website, writingsoftware.org, that has a ton of videos on why you need to work correctly and even how to videos and how to calculate certain things. The ideas I shared with you tonight, those who've taken the Architects Masterclass or the Project Design Masterclass are very well versed with it. Literally on each of the ideas I showed you tonight, I have next to a week worth of presentation at my pace. I will be doing one Architects Masterclass in California in August, and it's going to be in person, yay, and one project design in September. I'm also planning on visiting Israel in December for another Architects Masterclass. And more on these events and the masterclasses on iDesign.net. And so with that, let's open the floor for some questions.